Dear students, in this video, I'll explain you discrete probability distributions. We are going to discuss two discrete probability distributions. One is the binomial distribution and another is Poisson distribution. Already I explained you what is a probability distribution, the systematic representation of the values taken by the random variable along with its probability function is known as the probability distribution. Okay, particularly now I'll explain you what are binomial and Poisson distributions. If P is the probability of success and Q is the probability of failure, then probability of X success out of n trials. Probability of X success out of n trials is given by P of X is equal to NCX P to the power of X Q to the power of n minus X, where X takes the values from 0 to n. Also, Q is equal to 1 minus P, or else P plus Q is equal to 1. If X is a discrete random variable having probability mass function in the form P of X is equal to NCX P power X Q to the power of n minus X. This is the probability mass function of the binomial distribution. You need to remember this probability mass function. P of X is equal to NCX P power X Q to the power of n minus X. Then X comma P of X. X is the discrete random variable having the probability mass function P of X in the form NCX P power X Q to the power of n minus X is known as binomial distribution, and this X is a binomial variate. Okay. If we expand P of X for X is equal to 0 to n, definitely it takes the binomial expansion of the function P and Q. Hence, this distribution is known as the binomial distribution. Okay. Just you need to remember, if X is a discrete random variable having probability mass function in the form P of X is equal to NCX P power X Q to the power of n minus X, where X takes the values from 0 to n, then the distribution X comma P of X is known as binomial distribution. Okay. And now you don't have the derivation of the mean and standard deviation. Just you know what is the mean. Mean of the binomial distribution is equal to NP. Mean is equal to NP, and standard deviation is equal to square root of NPQ, or else variance is equal to NPQ. Okay, just you need to remember, but no need to learn this derivation. Okay. Next is the Poisson distribution. Poisson distribution is regarded as the limiting form of the binomial distribution. Okay. N is the number of trials. Suppose if the number of trials is very large means n is almost approaching to infinity, and P, the probability of success, is very small, that is P tends to 0, then the product n into P, n is the number of trials, P is the probability of success, tends to a fixed constant. We call that constant as m. In this case, we can show that the probability of X success out of n trials, that is the probability mass function of the binomial distribution P of X is equal to NCX P power X Q to the power of n minus X, takes the form P of X is equal to e power minus m to the power of x divided by x factorial, where x is equal to 0, 1, 2, 3, etc. Okay. If x is a discrete random variable, look at this, x takes the value 0, 1, 2, 3, dot, 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 means up to infinity, but it is countably infinite, hence it is discrete. Okay. If x is a discrete random variable having probability mass function in the form p of x is equal to e power minus m to the power of x divided by x factorial, x is equal to 0, 1, 2, 3, etc. Then the distribution x comma p of x is known as Poisson distribution, and x is a Poisson variate. Okay, look at this, the distribution on expansion. Okay, up to 0, 1, 2, 3, 4, dot, dot, dot. Okay, the corresponding probability values, when x is equal to 0, it is e power minus m. X is equal to 1, e power minus m into m power 1 divided by 1 factorial. When x is equal to 2, e power minus m square divided by 2 factorial. When x is equal to 3, e power minus m power 3 divided by 3 factorial, etc. Definitely, each of p of x is greater than or equal to 0, and summation of p of x, if we add all these values, definitely it comes out as 1 it is. Okay. Just you need to remember what is the probability mass function of the Poisson distribution. For the Poisson distribution, probability mass function is p of x is equal to e power minus m to the power of x divided by x factorial. Okay. What is its mean and standard deviation? No need to learn this derivation. Just okay, you need to remember the mean of the Poisson distribution is m, and variance is also equals to m. Okay, hence standard deviation is equal to square root of m. Okay, these are the two discrete probability distributions. Now we'll see what are the problems, what are the types of problems they're asking on these two distributions. Okay, first one, find the binomial probability distribution which has mean equal to 2 and variance is equal to 4 by 3. We need to find the binomial probability distribution. They have given the data. Okay, mean. Okay, mean of the binomial distribution is NP, its value is equal to 2, and variance is equal to NPQ. NPQ they have given it as 4 by 3. Okay, NP is 2. Okay, 2Q is equal to 4 by 3, or else Q is equal to 4 divided by 3 NP. NP is 2. Okay, 4 divided by 3 into 2, 2 2s are 2 by 3. Q value is equal to 2 by 3. So that P is equal to 1 minus Q. 1 minus 2 by 3 is equal to 1 by 3. And N, to find N, okay, NP is equal to 2. N is equal to 2 by P. 2 divided by 1 by 3, nothing but 2 into 3. 2 3s are 6. N value is equal to 6. So that probability mass function of the binomial distribution is p of x is equal to ncx p power x q to the power of n minus x, takes the form n is 6cx, p is 1 by 3 power x, q is 2 by 3 power n minus x, 6 minus x. Okay, this is a probability mass function for the given data. The distribution is as follows. Okay, for x is equal to 0, it is 6 0 is 1, 1 by 3 power 0 is 1, 2 by 3 power 6 minus 0, nothing but 2 by 3 power 6. For x is equal to 1, 6c1 1 by 3 power 1, 2 by 3 power 6 minus 1 5. For x is equal to 2, 6c2 1 by 3 power 2, 2 by 3 power 6 minus 2 is 4. For n is equal to 3, 6c3 1 by 3 power 3, 2 by 3 power 3 for all the values. Okay, for n is x is equal to 0 to 6, write on the corresponding probability function. Okay, probability values. This is the required probability distribution. Next one. When a coin is tossed 4 times, find the probability of getting exactly one head, at most 3 heads, at least 2 heads. Okay. When a coin is tossed 4 times, n value is equal to 4. Find the probability of getting exactly one head. In tossing a coin, what is the probability of getting head means when we toss the coin, total number of outcomes is 2. Either we may get head or tail. Okay. Probability of getting head means only one favorable outcome, that is head. Okay. So probability of getting head in tossing a coin is 1 by 2. Okay. Not getting head is q. Q is equal to 1 minus p. 1 minus p is also equal to 1 by 2. Okay. The probability of x success out of n trials is given by p of x is equal to ncx p power x q power n minus x. X is equal to 0, 1, 2, 3 up to n. Substitute the n, p, q values. 4cx 1 by 2 power x. Q is also 1 by 2 power 4 minus x. Okay. Their bases are same, we can add the powers. 4cx 1 by 2 power x plus 4 minus x plus x cancelled, 1 by 2 power 4, x is equal to 0, 1, 2 up to n. N means 4. So that probability of exactly one head, okay, they asked exactly one head means x value is equal to 1. If I substitute x is equal to 1 in the probability mass function, 4c1 1 by 2 power 4. Okay, 4c1 is 4, 1 by 2 to the power of 4. Okay, 2 square divided by 2 power 4, 1 by 2 square, 1 by 4, nothing but 0.25. That's the probability of getting exactly one head. Okay, probability of getting at most 3 heads, maximum is 3 heads. Okay, at most, okay, means probability of x less than or equal to 3. Maximum is 3 or less than that, at most. Okay, at most means less than or equal to. Probability of x less than or equal to 3 equal to less than or equal to 3 means which are the values less than 3? 0, 1, 2, 3. Up to that we need to find. Okay, in a complement way, it can be written as 1 minus probability of x strictly greater than 3. Which is the value greater than 3 means only 4. 1 minus p of x is equal to 4. 1 minus, when we substitute x is equal to 4 in probability mass function, 4c4 into 1 by 2 power 4. 4c4 is 1. 1 minus 1 divided by 2 power 4. Okay, that is nothing but 1 minus 1 by 16, nothing but 15 by 16. You can also write the answer in terms of decimals. At least 2 hits. At least 2 hits. Okay. Probability of at least minimum 2 hits or more than that. At least means greater than or equal to. P of x greater than or equal to. Which are the values greater than or equal to 2? Okay. That is 2, 3, 4. Okay. 2, 3, 4. Or else, okay, it is in a complement way, 1 minus probability of x less than 2. Okay. It is exactly greater than or equal to 2. It is a mistake. P of 2 plus P of 3 plus P of 4. It is P of 2 plus P of 3 plus P of 4 you need to find. P of 2 means 4c2 1 by 2 power 4. P of 3 means plus 4c3 1 by 2 power 4 plus 4c4 1 by 2 power 4. Okay. It's a mistake. You need to simplify this. Okay. Next problem is the probability that a pen manufactured by a factory be defective is 1 by 10. If 12 such pens are manufactured, What is the probability that exactly 2 are defective, at least 2 are defective, none of them are defective? Okay. Look at this. The probability that a pen manufactured by a factory be defective is 1 by 10. P value is equal to 1 by 10. If 12 such pens are manufactured, N value is equal to 12. Okay. Q value is equal to 1 minus P. 1 minus 1 by 10 is 9 by 10. Okay. We need to find these probabilities. Exactly 2 are defective, at least 2 are defective, none of them are defective. Probability of x success out of n trials is given by P of x is equal to NCx P power x Q power n minus x. When two datas are there, P and n values are there, means we need to use the binomial distribution for x is equal to 0 to n. Substitute the npq values. N is 12 Cx, P is 1 by 2 power 1 by 10 power x, Q is 9 by 10 power n minus x, 12 minus x, x equal to 0 to 12. Now, first one, exactly 2 are defective. Probability of x is equal to 2. Okay. If I substitute those x is equal to 2 here, 12C2, 1 by 2 power 1 by 10 power 2, 9 by 10 power 12 minus 2. 12 minus 2 is 10. If I simplify this, it comes out as 0.2301277. That is, by using the calculator, you can simplify this. At least 2 are defective. Minimum 2 or more than 2. Okay. Minimum 2 or more than that. At least means greater than or equal to, meaning it is probability of x greater than or equal to 2. Greater than or equal to 2 means 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to that length it is. That's why I have written that in a complement way. 1 minus probability of x strictly less than 2. Which are the values less than 2 means 0 and 1. 1 minus, okay. P of 0. P of 0 is 12C0 is 1. 1 by 10 power 0 is 1. 9 by 10 power 12 minus 0 is 12. 9 by 10 power 12 plus P of 1. 12C1. 1 by 10 power 1. 9 by 10 power 12 minus 1 is 11 it is. Okay. If I simplify this, 1 minus of, first you need to add these two values. Then subtract that sum from 1. It comes out as 0.340997748. Next is none of them are defective. None means x value is equal to 0. P of x is equal to 0. That's equal to 12C0, 1 by 10 power 0, 9 by 10 power 12. 12C0 is 1. 1 by 10 power 0 is also 1. 9 by 10 power 12 comes out as, this is the answer. Okay. Next is, in a consignment of electric lamps, 5% are defective. If a random sample of 8 lamps are inspected, what is the probability that, okay, 1 or more lamps are defective? Okay, here also, in a consignment of electric lamps, okay, in a lot of electric lamps, 5% are defective. Probability that the defective lamps is 5%. Okay, 5 by 100, nothing but 0.05. Q is equal to 1 minus P is equal to 0.95. If a random sample of 8 lamps, N value is equal to 8. X denotes the defective lamp test. Probability mass function is, okay, P of x is equal to NCx P power x Q power n minus x, x equal to 0 to n. Substitute NPQ values. 8Cx, 0.05 power x, 0.95 power 8 minus x, x equal to 0, 1, 2, 3 up to 8. Probability of 1 or more lamps are defective. 1 or more means x greater than or equal to 1. 1 to 8 we need to find. Okay, in a complement way, it is 1 minus probability of x less than 1, which is the value less than 1 means 0. 0 is only the value less than 1. 1 minus p of 0. If I substitute x is equal to 0 here, 8 is 0, 0.05 power 0, 0.95 power 8 minus 0. Nothing but 1 minus 0.95 power 8. It comes out as 0.3365 something it is. Okay. I hope you are following, right? The probability, next problem, the probability that a person aged 60 years will live up to 70 is 0.65. Okay, the man aged 60 years, he will live up to 70 years is 0.65. That is p is equal to 0.65. Q is equal to 1 minus p. 1 minus 0.65 is 0.35. What is the probability that out of 10 persons, n value is equal to 10. Out of 10 persons aged 60, all the 10 persons are aged 60, at least 7 of them will live up to 70. Okay, we need to find x denotes the number of persons aged 60 live up to 70. We need to find at least 7, minimum 7 or more than 7 persons will live up to 70 years. Probability mass function is p of x is equal to ncx p power x q power n minus x. X takes the values from 0 to n. Okay. Substitute n p q values. N is 10 cx, p is 0.65 power x, q is 0.35 power 10 minus x. N minus x means 10 minus x. X equal to 0 to 10. X greater than or equal to 7. Okay. At least 7 means greater than or equal to 7. Which are the values greater than or equal to 7 means 7, 8, 9, 10. P of 7 plus P of 8 plus P of 9 plus P of 10. Okay. Substitute x is equal to 7. 10 is 7.65 power 7.35 power 10 minus 7 plus P of 8. 10 c 8.65 power 8 plus into 0.35 power 10 minus 8 plus 10 c 9.65 power 9 into 0.35 power 10 minus 9 plus 10c 10 0.65 power 10 0.35 power 10 minus 10. If I simplify this, okay, it comes out as 0.5138 to 7. Okay. In the next video, I'll explain you some more problems on this. Okay.